This is Algebra 2, Lesson 21 on page 101. But we're going to start on page 102. The first part of this lesson is scientific notation. Tell me what you know about scientific notation. Tress.
Shorthand way of writing very large or very small numbers.
Correct. It is a shorthand way of writing extremely large, like 323 trillion or 0.00000000035, right? Shorthand way. It is used a lot in what subjects? Chemistry, which you should be using it in, right? But it's also used in physics. So any of your math, sciences, it is used in. What is the rule of, or the proper form for writing scientific notation? Yes,
With
Mackenzie.
one digit to the left side of the decimal point and the rest to the right.
Correct. Only one digit to the left. And it has to be one digit. And that digit has to be between 1 and 9, not 0. Got it? And then everything else to the right of the decimal place. All right. What if I wrote this on the board? What does that 10 to the negative 3 tell me to do?
You need to move your decimal place 3 places to the left.
3 places to the left. If I want to know the original number, right? 1, 2, 3. So if I am given let's put some more zeros. So if I'm given this decimal and want to go to scientific, when it is a very small number, my exponent for 10 is going to be negative. Because what it tells me is where I put, what direction I move the decimal place back to write the original decimal. All right, so this would really be 5.62 times 10. And I count 1, 2, 3, 4, 5. And it's negative because it's a very, very, very small number, okay? So that negative is when I move the decimal to the right, which feels sort of contrary to like a number line. But really the negative says, which direction do I move the decimal back to the original number, okay? All right, the same is true if I had 100, that 1.35 times 10 to the 5th. That tells me 5, positive, says move the decimal to the right by 5 places and you can have the original value. So if I have a very large number, then I know my exponent is going to be positive. And always we have one digit to the left of the decimal place. I look and I count back 1, 2, 3, 4, 5, 6, 7, 8, and it's a positive because it tells me I move it back in the positive direction to go back to the original number. All right, so we can convert values to scientific form. Now, what if I had, let's make this easy. What if I have scientific notation and I'm multiplying them? Yes.
The
For the tens, we're going to add the exponents, right? Because multiplication is addition. For the numbers that have the one digit to the left, so for the tens, we're going to add. Really, you're multiplying first and last. This is not FOIL. This is not foiling. Because this is a single value. This is like 2, 5, 1, 2, 3, 4, right? Times 0.002. Right? If I were to go back and rewrite them in their original form. You agree? So we're only multiplying the first, and then we're multiplying the tens. You can separate these. So it's 2.5 times 2? 5. That's why I wanted to make it easy. All right? So you can separate the first parts and the second part. Yes, Therese?
Do you need a decimal at the 5?
You absolutely need a decimal. 100% of the time, you need a decimal. All right? Now, what if I had, again, I'm going to make it easy. This really is a single term times a single term, and then I divide that result by a single value. Well, I can separate the first part of the numbers, 3.0 times 4.0 divided by 2.0. I can separate them from my factors of 10. 10 to the 5th, 10 to the negative 1, 10 to the negative 3. I made it easy. This is 12. Half of 12 is 6. So this would be 6.0. Multiplication is addition. Division is subtraction. So we'll add and we'll subtract. 5 plus negative 1 is 4 minus negative 3, 7. 4 minus negative 3 is 4 plus 3. Okay? All right. So let's work the practice problem. I'm on page 102. All right, the first thing we want to do is to write every term in proper scientific form. None of these is in proper scientific form. Because this is a smaller number, when I move the decimal place, what am I adding? A positive or a negative number? A negative number. All right, so it's going to be, this first term is going to be 3.0 times 10. How many negatives? 1, 2, 3, 4. So it's going to be 10 to the negative 10. I'm adding more negative because it's a small number. All right. What is 4,000 going to be? 4.0 times 10 to the third. All right. Because that's a small number. When I add it, when I move the decimal place and add those numbers, is it going to be positive or negative? Negative. All right, so it's 6.0 times 10. How many negatives? 1, 2, 3. 3 negatives to 15? 12. And then this one, am I adding a positive or a negative?
Positive.
Positive, because it's a big number, and I add 3 to 4, which is 7. Now I can break it apart. 3.0 times 4.0 divided by 6.0. They also made it easy. Not all of your problems are this easy. Times 10 to the negative 10th. Let's go ahead and add our numerator. Negative 10 and 3.
Negative 7.
Negative 7. Let's add our denominators. 12 and 7. 18. All right, this is 12 over 12.
It's 19, I think.
Not set. It's 19. Yes, it is 19. I wanted it to be an even number. All right, so we end up with 1.0 times 10. Division and subtraction. 7 minus 19 is negative 26. Therese, you had a question?
No, ma'am.
All right, got it? All right, the second part of this lesson, we have already really worked these types of problems. It's called two statements of equality, which ends up being a proportion typically, or if we have two statements, so two statements of equality can be 8 over 6 equals x over 5. That can be two statements of equality. Or we can have what we've already had, nickels plus dimes equal 40, 5n plus 10d equals 300, something like that. That's two statements of equality. How do we solve for two statements of equality if they're like this? Two ways.
Substitution or elimination.
Substitution or elimination. Okay, don't forget that. Substitution or elimination. Those are linear equations, and we will always use substitution or elimination. If it's a ratio, we're going to cross multiply, right? All right, so let's look at these examples on the bottom of page 102. 21.2. The ratio of two numbers is 3 to 4. All right, ratios can be written like this. I'm going to write 3 to 4 like that. All right, equals numerator, denominator. And their sum is 84. Actually, I could just do XY. Probably that's what I prefer, XY. And their sum, if, I don't know that it's 6, their sum is, what is their sum? 84. All right, we have two statements of equality. What are my options? I can use either, Ashley said it, substitution or elimination. All right, what would you like to do? Substitution or elimination? You want to? I want to do substitution. All right, so I would take this second equation, solve for x or y, and substitute into the ratio. You could cross multiply, solve for x and y. That seems to be more steps to me. All right, so y'all want to solve for x or y?
Okay.
X. So x equals 84 minus y. So then I'm going to go back to this first equation and substitute 84 minus y in for x. Then I will cross multiply. Because then I only have one variable. Always, when you have multiple equations, you want to end up with one variable because that's all we can solve for till you get next year. All right, so we cross multiply. 4 times 84 minus y equals 3y. Let's do it in our heads. What's 4 times 84?
336.
Minus 4y equals 3y. Add your 4y to both sides. We have 336 is 7y. When you divide by 7, what does that equal? 28. 56.
48.
48 is y. it's easier to go back here in this equation where you solve for the other variable and substitute that 48 back in. X is 84 minus 48. What's the value of X? 36. So what are my two numbers? 36 over 48. That is the exact same ratio, 36 over 48. What did I multiply to get to that ratio? This ratio is how many times the first one? Oh, come on. 12. 3 times 12 is 36. 4 times 12 is 48. That will always be true if it's like this. Here's what you're used to doing. You're used to simplifying, going 36 to 3 and 48 to 4, right? Are y'all awake? Maybe. You following me? All right. Let's look at the next example. The sum of two numbers is 128. I'm just going to label those two numbers 1x, 1y. And their difference is 44. I'm keeping them in the same order. All right, how do you want to solve this one? Yes, Corinne? I absolutely want to eliminate because my y's have the same, have the same coefficient, opposite sign, right? So when I add them, my y's eliminate. I'm left with 2x equals, that's 12, 172. What happens when we divide by 2? What's the value of x?
86.
Yes. 86. If x is 86, then what do we have to add to 86 to get 128? What must y be? 42. Is their difference 44? It is. You see how I just quickly checked to make sure their difference was 44.